All right, so I'm back. We're working with Nvidia Nemotron Super 120B, and I just finished setting up the parameters moving over from Llama and turned off all the open web UI kind of settings to get it optimized that way. But now this is a fresh, clean install, and just as a reminder, we're working with these two Spark or these two DGX devices, but they're not actually clustered right now. What we're trying to do is demonstrate what it's going to be like to work in a server environment, a client server environment, where the one to the right, that's the server, and the one to the left is the client. And essentially, they're doing parallel processing, not your typical pipeline processing or parallel processing. It's just two separate instances of Unix or Linux walking around and doing their daily work. And now they've gone ahead and done some queries. The query that we're going to do is tell me about pterodactyls on the server device. That's misspelled on purpose. And on the client device, we're going to say, tell us about Saturn. Okay. Before anything else, 120 gigabytes of memory, 90 something percent use on the server. No memory being used at all on the client because they're independent of each other. So let us begin the query. 1, 2, 3, go. So you can see the prefill stage has begun. I'm trying to zoom in there really fast, but if you take a look over there, the CPU usage is going way up. So, or GPU, I guess. It's 93% already. And because we're not clustered, there's really not much going on that side there. The prefill looks good. The tokens per second looks decent. Again, this is a 120 gigabyte model, and it's supposed to be really slow. And I have another video that we did this on using Llama, which is not fine-tuned for the Spark devices, and it was drastic. It was really pretty bad. You're looking here at maybe 15 to 20. Definitely usable of token speed. And again, these are two runs going on at the same time. I wish I could really stage it where we have multiple systems, but imagine a small business where you have this specific setup. That's a developer machine over there, and that's the server. The developer is querying something from the code base, and at the same time, another person is doing something work related. Well, I guess you could say work related. The coding is work related. But anyways, taking a look at the graphs here, you can see that the CPU usage is pretty crazy on the server side of things. There's at least one core that's allocated to 100%, and it's going to be these two over here, all over the place. We haven't gone into swap yet, right? Because everything's been pretty much being used at the memory level, which is pretty impressive. Again, this is a 120 billion parameter model quantized down to what feels like 12 billion parameter model. But yeah, it's chugging along and busy. But take a look over here, right? Nothing's going on there. The query is going fine. So yeah, that's the user experience, or at least the multi-user experience when you have an unclustered environment. Now, the bigger question is what happens when the context window gets big. Right now, we're looking at 75% utilization, memory utilization. So 75% of the memory is being allocated to doing that, and the rest going to KV swap. What starts to happen when you've gone ahead and spent the whole day doing multiple queries, or you've gone ahead and started dropping documents in to this model? So that's kind of what you want to do and watch and track over the long term. But at least here, from a newly loaded environment or newly loaded model into the environment, your token speed is decent. And I tried this the other day on a Mac Studio with 96 gigs of RAM, despite having a much faster memory bandwidth. I think it's 4 times the speed. it's crawling because again, this is a bigger model, and what happens with bigger models for the Mac with a smaller amount of memory, again, that's 96 gigabytes of memory, you're fully reliant upon the amount of RAM that you have instead of the speed of it. So RAM is king. So there we go. Nemotron 3 Super 120 billion quantized down to Nvidia floating point 4. Oh, this one just went ahead and completed. Let's do something interesting. Let us actually do a follow-up query. Well, that one's still going on the top, but let's click on it. It says, how large were pterodactyls and what was their wingspan? Okay, go ahead and click on that. There we go again. Very fast prefill. Inference is 2 stages, right? One is prefill and the other one is on the actual decode. And what I really love about DGX, the DGX platform, is that the prefill stage is almost instantaneous because of the architecture that they have that loads everything up into memory. Again, this is a 120 billion parameter model quantized down to what feels like it's a 12 billion parameter model. So it gets that kind of speed. Over here, that's completed. I'm going to do a follow-up there as well. I'll wait for it to actually load up the suggestions. Let's take a look. In summary, Saturn is a dynamic, complex world. I'm still going. I'm going to click on here and say, tell me more. Tell me more. See? Prefill is fast. Let's touch the... you can feel this device working and the other one not so much. Yeah. But the fans aren't on yet. Normally when it gets really busy, the fans get crazy. But we're still doing okay. So definitely usable. And I'll post a link in the description with the 70 billion parameter model. And that one is not MOE, or model of experts. It's significantly slower, almost to the point of unusable. So, all right, thanks.